a couple people.
Oh, I'm going to tell on you. Okay. There we are. Yes. Yes. Today is going to be interesting. Okay. So let us begin. We're going to be solving not quadratic equations necessarily, but rational equations. That is, equations with fractions. And I know you already know the basic idea, but we're just going to review the whole thing. So here's the first one. Number 1. Four over 7 plus 2 over 21 equals 1 over x. And here's the strategy. I'm going to write that in blue. The strategy is this. If you have something like, okay, you've got a fraction term, I'm not going to have room, so let's go down here, strategy. We're going to use the same exact strategy for all the problems here. Okay, if you have a fraction term, let's just say a frac term. Frac term plus frac term equals, and whatever this is, it could be a number, it could be anything. It could be a fraction like up here. You are going to use the same exact strategy to solve this problem. In fact, you use the same exact strategy to solve any fraction problem. That is step 1, STRP. STRP 1, you calculate an LCD. And we're going to talk about how you do this. It's nowhere near as hard as the way you were taught in elementary school or middle school. Calculate an LCD. And I'm going to make that in red. For a reason, you'll see. And then STRP 2. Maybe not, maybe just step 2. Calculate each term by the LCD. There's a reason for that. Step 3 is the reason. Cancel out all your denominators. And step 4, solve the equation. Okay, so I mean, that's not the neatest in the world, but that is the idea. So let's rewrite this equation. And I'll show you, it's better than this up here. This will be a better example. Okay. All right, so I have 4/7. I'm making lots of room between the terms. 2/21 equals 1/x. Okay? Now, I'm going to calculate an LCD. Calculate, that was supposed to be multiply. Multiply each term by an LCD. Step 2, multiply each term by the LCD that you've just calculated, multiply. Well, we are going to do that, but let's say I already have an LCD and I call it LCD. What I'm going to do is I multiply the first term by the LCD. And I multiply the second term by the LCD. And I multiply the third term by the LCD. And that permits me to cancel out the denominators. As you'll see, we're about to do it. So step 1, we're going to calculate the LCD from this and this and this. So here are the steps to calculating an LCD. Again, I think this is so much easier than what the public schools teach in the lower grades, but they've changed the way they teach. So I have no idea how they teach anything. Terrible. I need to take a class in that Common Core. I really do, in the math part anyway. Okay, so steps to calculating an LCD. Okay, step 1. Put each denominator next to each other and separate them by a comma. So here we go. These are the denominators right here, 7, 21, and x. So I am going to write down 7 and 21 and x. Those are my 3 denominators. Okay, now step 2, consider the 3 terms. Well, consider the denominators. Or maybe I should say something like factor the denominators. That's better. You know, you do something and you get used to doing it, but you don't really think about putting it into words. So it's good to be forced to break it down into words. Denominator. Okay, so I have a 7, I have a 21, and I have an x. Well, 7 won't factor. It's a prime. You can only factor it into 1 times 7. But 21 factors into, as we know, 1 times 21 and 3 times 7. So if I were going to list the separate factors, it would be 1, 3, 7, and 21. And then X, I have no idea what X is. So I'm just going to say X and 1. Now, so here's the factorization of 7, not very interesting, like the factorization of X, which is not interesting. And then 21 is interesting, particularly because look, 7 is in 21. So if you write 21 as part of the LCD, it's already inside 21. 7 is already inside 21. So while you could write a common denominator like this, lowest, notice it's not lowest, just any old common denominator. The way you do that is you just multiply the denominators. Just multiply. I would have 7 times 21 times X, which would be 147X. That would be a common denominator. And I could multiply every term by that, but I'd end up having to cancel again. So, an easier way when it comes to multiplying, the smaller your numbers, the easier it is writing a lowest common denominator. And for that, we need this factorization I wrote down. Denominator. Okay. This takes into account the fact that if I write the number 21, I'm automatically also including the number 7, because 7 is one of the factors of 21. So a much smaller and much better common denominator is the lowest common denominator, which is going to be 21x. Because the 7 is already in there. So a common denominator is just multiplying all the denominators together. And it's not wrong, and you can get the right answer, but it gets harder. The lowest common denominator is the safest common denominator, and all that is 21x, and look at how much smaller it is than 147x. Okay, now I am going to go up here and look at that and do this. So I've got my 4/7 again, plus 2 over 21 equals 1 over x. And I am going to do the following step in red. My common denominator is 21x. All of these are fractions, so I'm going to put 21x into fraction form, which is 21x over 1. That's not bad. Okay, here I go. It doesn't matter whether I put it in front or behind. So I have now multiplied each term by 21x. And I've just written it as a fraction by putting it over 1. Here's what that does. Remember from yesterday, when you multiply fractions, you eventually end up multiplying the tops and multiplying the bottoms. So I can do this. Most people don't go to this extra step, but you can definitely do it. 21x times 4 over 7 plus 21x times 2 over 21 equals 21x times 1 over x. And now I can cancel. 7 goes into 7 one time. 7 goes into 21 3 times. 21 and 21 go into each other one time, which is the same thing as canceling. And x goes into x one time, so that's the same thing as canceling. So now the equation I've got, I'm going to start on the next page, is going to be 3 times x times 4 over 1. People usually don't go to this step either, but you can, because I want you to see at least once what's happening. Plus x times 2 over 1 equals 21 over 1, which of course you can do. But let's face it, anything you put over 1 is just itself. So this is going to be 3 times x times 4, which is 12x, plus x times 2 is written 2x, equals 21. Now this is the equation we have to solve. And this doesn't have any fractions in it. We have just killed all the fractions. Temporarily. Maybe temporarily. Let's see. So I've got 12x plus 2x. Well, that'd be 14x. Equals 21. I'm going to divide by 14 and divide by 14. Boom, boom. I'll have x equals, well, this is going to be 21 is 7 times 3 and 14 is 7 times 2. The 7's cancel, leaving me with 3 over 2. So x equals 3 over 2. And you can check it or not. I usually don't check answers when they're fractions. Yes, yes.
I got 1.5.
Same thing. Same thing. If you put 3 over 2 in your calculator and hit enter, it'll give you 1.5. So very good. Very, very good. It depends on what they're asking for. And here, oh, yeah, we would have to go through a lot of steps. That first one, you're going to have to go through a lot of steps. See this blue thing down here? That means there are a lot of separate questions, which I really don't want to take the time for. More discussion, more questions. Okay, this is our goal. We're going to have a bunch of terms, and there are fractions in them. It's an equation, so there will probably be fractions on the left of the equation and fractions on the right of the equation. Every single time we are going to write each original term by the LCD. And we get the LCD by placing the denominators, the individual denominators next to each other, and then factoring them and seeing what they have in common. With the idea that you're going to use like 7, the common term, to cancel out denominators. And we're going to do that over and over, and you should do it with me, all of you, so that you can get the practice, so when you get home alone, you don't freak your freak. Because nothing can make people freak out quicker than fractions. Okay, here's number 2. We have x over 3 minus x over 4 equals 12. And right now I'm going to say over 1, just to be consistent. Now, I'm going to write my denominators, 3 and 4 and 1, and I notice immediately, with great heartbreak, they have nothing in common. 3 is not a factor of 4, 4 is not a factor of 3, but of course 1 is a factor of every number. So I have no choice here. My common denominator, which would be common denom, let's just say denom. My common denominator is going to be 3 times 4 times 1 equals 12, and my lowest common denominator, how about LCD? My LCD is going to be 3 times 4, which is 12. This is one of those cases where the LCD and the CD are exactly the same. So, without further ado, I am going to multiply by 12 over 1 and 12 over 1 and 12 over 1. And 3 goes into 12 4 times. 4 goes into 12 3 times. And nothing much I can do here, but at least the denominators are gone. So I am going to write 4x minus 3x equals 144. 4x minus 3x is 1x. Oh, no problem. X equals 144. Well, is that a dinky problem or what? Discussion? Ends up that's not much of a problem. Well, we need something else to keep you brilliant people interested. How about this? Number 3. Three over x minus 2 equals 4 over x plus 1. Okay. So I have x minus 2 and I have x plus 1. Now, I'm not doing any of this partial fraction decomposition that a number of Algebra 2 students in high school are taught. Just basically, I can say in all truth, x minus 2 is not a factor of x plus 1, and x plus 1 is not a factor of x minus 2. So this is another case in which the CD, the common denominator, is going to equal the LCD, the lowest common denominator. So I'm going to multiply both terms by the LCD. And the LCD, let's write LCD. LCD and LCD. And my LCD, while we're at it, is going to be x minus 2 times x plus 1, or if you wrote it, x plus 1 times x minus 2, that's exactly the same thing. Okay, let us go. We are going to have x minus, well, I really want to go back to black. X minus 2 times x plus 1 over 1 times 3 over x minus 2 equals, I usually put this answer first, and then x minus 2 times x plus 1 over 1. Okay. Now, x minus 2 and x minus 2 cancel. X plus 1 and x plus 1 cancel. And I am left with an x plus 1 and a 3. So 3 times x plus 1 equals 4 times x minus 2. And then I'm going to multiply the 3 by the x and the 3 by the 1, and the 4 by the x and the 4 by the minus 2. In other words, I'm going to distribute. So 3x plus 3 equals 4x minus 8. And now I'm just going to solve this problem. I'm going to subtract 3x from both sides. We're going to have another 4x minus 3x is 1x. I'll have 0 plus 3 equals 4x minus 3x is x, 1x. Bring down the minus 8, and then add 8 over to both sides. Negative 8 plus 8 is 0. 3 plus 8 is 11. 11 equals x. The one thing you do have to be careful of is if this number could make either of these denominators equal 0. But 11 is not a problem. 11 minus 2 is 9, 11 plus 1 is 12. It's not a problem. How is this? Any questions? Any discussion?
Yes, can we go a little slow, Barbara?
Oh yeah, I thought maybe I was going way too slow, but I'm not. Good, I must be talking too fast. Yes, I am more than glad to sip on my coffee in between. So let's go back to anything you didn't understand. This is the only thing we're doing today. So we have plenty of time.
Go ahead and another one.
Okay. Now they're getting interesting. Okay. Why is it that when math teachers use the word interesting, that always means harder? Just a problem of the craft. Okay. 70 over y minus 70, 70 over y minus 8 equals 2 over y. Okay, so I'm going to multiply, well, I'm not. I'm just going to look at the three denominators. Y minus 2, and y. Well, y is a factor of y.
Miss Barbara?
Yes?
I think you meant y minus 8.
It's right there. No, I didn't. Oh, did I do that? Thank you. Doggone, you can't trust me. I can't trust me. That's a problem. Okay, now. The y's are factors of each other, so I only need to write that once. But neither of these y's alone is a factor of y minus 8. There's nothing you can multiply y by, no one thing, to get y minus 8. Besides this, there would have to be a y in each of these terms that could factor out before y all by itself could be a factor of that. So, I have two factors that will not go evenly into each other, y and y minus 8. So my LCD is going to be y times y minus 8. Okay, any discussion about that before I go on?
So the only thing that's in common is the y. So why are we putting the y minus 8?
Because it also is one of the denominators. I can't just throw it away.
Okay.
That is a very good question. Thank you. Anybody else? Yeah, you have to use all your denominators unless you find out that one denominator is totally a factor of another denominator. Okay, so I am going to let this LCD be LCD over 1 here. And I'm going to multiply each of these terms by that. So I will have y times y minus 8 over 1 times 70 over y minus y times y minus 8 over 1 times 70 over y minus 8 equals 2 over y times y minus 8 over 1. So that now is kind of my second line, if you will, of this equation. I go over here, or wherever you want to go, and calculate the LCD. And one of the most fun things about LCDs is that they cancel out denominators. That's the main purpose of an LCD. So this y and this y are going to cancel each other. And this y minus 8 and this y minus 8 are going to cancel each other. And this y and this y are going to cancel each other. Again, the main thing you do with a lowest common denominator or a common denominator is you cancel out denominators. When you've got an equation, you can't go around canceling stuff if you don't have an equation. I mean, not without being very careful. Discussion at this step. Okay. Well, there's an understood 1 here where there was complete cancellation. Okay, so all of my bottoms are going to be 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1. So everything is over 1. On top here, I have a y minus 8 left and a 70 left. So I'm going to write that as 70 times y minus 8. And then minus, I have a y left and a 70. So that'll be 70 y. And then equals, I have a 2 left, and I have a y minus 8, so 2 times y minus 8. And now I have a normal linear equation, which is going to be fairly easy to solve. I'm going to have distribution, but other than that, it's better than fractions. Any discussion at all? Excuse me.
In the negative 70, where did we get the y?
Right here. It did not cancel out of that term. The y minus 8's canceled, but that left a y out here. Since the LCD is y times y times y minus 8.
Gotcha. Thank you, Miss Barbara.
You're welcome. Anybody else? Okay, well, I'm going to go on and distribute now. I take 70 and multiply it by y. 70 and multiply it by -8. Over here, I'm going to take 2 and multiply it by y, and 2 and multiply it by -8. So let's see, that will give me 70y minus 560 minus 70y equals 2y minus 16. And I'm going to get my calculator and double check. What have I got? 70 times 8. I just want to make sure. Clear. 70 times, that's not a times 8. Yep, okay. All right, so 70y minus 70y, these guys are going to zero out, leaving me with -560 on the left, and on the right I'll have 2y minus 16. Then I'm going to add 16 to both sides because I have to solve for y, and plus 16. So, hello? Yes, I have 560. Let me multiply it by -1 because it needs to be, no, needs to be a negative number. It's -560. Oh, you go to. Okay, I'm just going to say -560 plus 16. -544. -544 equals 2y, because this is 0. Now I'll divide by 2 and divide by 2. So -544 divided by 2 is -272. That's a weird answer. I'm going to see if it's right. -272 doesn't feel right, but it is. So let me move down a little bit here. So you've got the entire program in front of, entire equation in front of you. And we can discuss this and discuss any questions you might have. Okay. Yeah, had to happen. Number 5 in your homework. Excuse me. We're going to have z over z minus 11 plus z over z squared minus 121 equals z plus 12 over z plus 11. And that's my equation. So for our very next step, what we're going to do is go back to the first page for just a minute. And notice that what I did somewhere, yeah, this step right here. What I did here was I calculated the LCD by factoring everything. Well, here, I'm going to do much the same thing. I'm going to write, and I don't have room over here for all this, so I'm going to write the three denominators right here. Oh, no. Okay. Z minus 11 can't be factored. I mean, that's already in lowest terms. It's just your basic linear binomial. So is Z plus 11. However, Z squared minus 121 can be factored as the difference of squares if you know that Z squared minus 121 is Z squared minus 11 squared. 11 times 11 is 121. So if you know that, or quite honestly, if I saw Z squared minus a number, I would try to take the square root of it, the principal square root, go square root 121, and just check it out. So you know from yesterday that, actually you know from last week, that the way you factor the difference of two squares or by the difference of two squares is you take the first term squared, and so you unsquare it, you take the square root of it. The square root of z squared is z, so z and z, and the square root of 121 is 11, the thing in parentheses there, so you take the 11 and the 11, and then you put a plus here and a minus here, and that is the factorization of z squared minus 121. Now at this point, notice z minus 11 is in z squared minus 121. It's one of its factors. Z minus 11 is a factor of z squared minus 121. And z plus 11 is a factor of z squared minus 121, and here it is right here. So z minus 11 is one of the factors of z squared minus 121, and z plus 11 is one of the factors of z squared minus 121. Both of these are inside z squared minus 121. So our LCD is going to be z squared minus 121 equals C Z 11, 11 plus minus. That is going to be our LCD. So now I'm going to rewrite this equation with each term multiplied by Z plus 11 times Z minus 11 all over 1. Okay, so here I go. Well, in a minute. I worry about people who can't see red, so I'm going to use this color. Okay, so Z plus 11 times Z minus 11 over 1 times Z over Z minus 11 plus Z plus 11 times Z minus 11 over 1 times Z over Z squared minus 121, but I'm going to write it in factored form. Z plus 11 times Z minus 11 equals Z plus 11 times Z minus 11 over 1 times Z plus 12 over Z plus 11. Whew! I needed to start out writing smaller. But that's what I've done. Let me double check it. Z plus 11 times Z minus 11 over 1 times Z over Z minus 11 plus Z plus 11 times Z minus 11 over 1 times Z over Z plus 11 times Z minus 11 equals Z plus 11 times Z minus 11 over 1 times Z plus 12 over Z plus 11. Now I get to cancel. Z minus 11 and Z minus 11 cancel here. And what I'm left with is a Z plus 11 and a Z, so I'm going to write it right here. Now look at this, Z plus 11 and Z plus 11 cancel. Z minus 11 and Z minus 11 cancel. So all I've got is a Z. Over here, Z plus 11 and Z plus 11 cancel. So I'm left with Z minus 11 times Z plus 12. And that's going to be the equation that I solve and get a value for Z, and then I have to do a quick check to make sure it doesn't cause any of the denominators to go to 0, to equal 0. So discussion up to this point, right here. Okay, so let's go. Z times Z is Z squared, plus Z times 11 is 11Z, plus Z equals, going to multiply, multiply, and multiply, multiply. And that'll give me Z squared plus 12T, a Z, minus 11Z, minus 11, negative 11 times positive 12 is 11 times 12. 132, so negative 11 times positive 12 will be negative 132. And so this is a squared. We'll have Z squared plus 11Z plus 1Z is plus 12Z equals, I'm going to move things over so I have more room. I'll have Z squared plus 12Z minus 11Z is going to be 1Z plus Z. That's right. Yeah, that's right. All right, minus 132. So that's what I've got right now. Well, my motivation for starting to subtract terms from each side is that this is a quadratic, and so I have to move everything from one side of the equation to the other side. But the very instant I subtract Z squared, and I may not have noticed this before, but Z squared is going to zero out on both sides of this equation simultaneously. Z squared minus Z squared is 0. That leaves me with 12Z on the left side of the equation, and Z squared minus Z squared is 0. And I'm left with Z minus 132 over on the right side. Well, 0 minus 132 is negative 132. So let's clean this up before I go on. Okay, I'm going to subtract Z from both sides because I need to get my Z terms together. That'll be 11Z on the left. Z minus Z is 0. Yep, negative 132. Then I divide both sides by 11. And Okay, divided by 11. Oh, heck. All right, well, let's math bracket and see. 44 over 37. Okay. So Z, much to my chagrin, is going to equal negative 132 over 11. Really? I don't believe it. Yeah, I guess it's true. It's not 44 over 37. So let's do it again. What? Yes?
I don't know if I'm right or wrong, but I got negative 12.
I thought I was going to get something.
So did I. I got negative 12 as well.
Oh, I'm glad. Yeah, I have no idea what I was doing. All right, cool. Yay, yay us. Now, just real fast and mentally, I'm not going to really do it physically. I'm going to go back here to the very first line, and I'm going to mentally plug in negative 12. Because we're saying Z is negative 12. If I put a negative 12 here, I'll have negative 12 minus 11. That is not 0. And since Z squared minus 21, 121, factors into this, if I put a negative 12 in either one of those, I will not get 0. And if I put a negative 12 in for Z over here, I will not get 0. So negative 12 is a wonderful answer. You do have to double check it though. Okay, we've got time for one more. See, what is the ugliest, dirtiest problem? Oh, okay, let's do some word problems, although they are not ugly and dirty. Let's look for one that is the most likely to be. I've seen this one on the final exam. Okay, I don't write my final exams, just in case you wondered. So I have to guess just like you. We're supposed to start, I thought we were going to start this semester, just writing the whole final exam ourselves, each individual teacher. But apparently it's not until spring. So I, like you, have to guess. Now the trout problem has appeared more than once. Let us do the trout problem. This is number 8 in your homework. To determine the number, oh, and this is true, by the way, so you might find it interesting. To determine the number of trout in a lake, a conservationist catches 166 trout. Poor trouties. Tags them and throws them back. Yes. Okay. Catches and tags. I do love fish, actually. Later, when later? We don't know. We don't care. Later, 39 trout are caught. "13 of them have tags." How many trout would the conservationist expect to be in the lake? So what this is this is a proportion problem. Oh, yes, okay. He's late today. Here's George. Just letting you say hello to the nice people. Okay. All right, so let's look at this. Here's a lake. My rendition of a lake. Okay. Now, this conservationist catches 166 trout. Out of all the trout swimming in the lake, the conservationist catches 166. How many are in the lake? I don't know. There are X fish. If I don't know how many fish, there are X fish. Sounds like the sequel to X-Men, X fish. All right. So I could set this up in the following way. There's a larger group of fish and a smaller group or a caught group. A larger group and a caught group. Let's call it caught. So you get to be a little creative. Caught group. That is, there's a larger group from which the group is caught. And these guys are all tagged. So it would have been better even to say a tagged group. But anyway, the larger group, if we let the larger group be all the fish in the lake, then the conservationists caught 166 of them and tagged them. Later he comes back and he catches a bunch of fish, here 39. And 13 of them are caught, are tagged. Now, at this, I am inclined to change my categories into large group, and tagged group. Okay, I like that better. Tagged group. The tagged group comes from the larger group. I mean, where else are they going to come from? Fish from outer space. X-fish. Aha, we're creating a novel. Maybe a graphic novel. I don't want to do it. Somebody want to do it? I've made you rich. Remember me later. All right, so number of fish in the lake over tagged fish equals larger group over tagged. There you go. This is a proportion. And this is actually how the number of animals in a specific area are estimated. You never get an exact count. You have to estimate based on this way of doing things. It's called a proportion. Okay, now proportions are really cool. You can do them in a couple of different ways. Maybe you remember cross multiplying. You can cross multiply. But today what we're talking about is using an LCD. So notice this, that We have fractions here. So that makes this a rational equation, which means we multiply both sides by the LCD. That means I'm going to look at 13 and 166. Now I already know that 13 doesn't factor into anything but 1 and 13. If you're looking at integers, which is what we are. We're not looking for a third of a fish. Okay, we just want whole fish, not negative fish either. Okay, would negative fish be dead fish? Fishies who've gone to fish heaven? I don't know. So I'm going to factor 166. In particular, I don't care about factoring it. I care, does 13 go into 166? I doubt it, but let's see. No, doesn't go evenly. Okay, so these are two separate numbers. Now, if I actually multiply them, I'm going to get a really big number, so I'm going to be sneaky. Here's the LCD I'm going to use. I'm going to multiply these, but you'll see what I do. I'm going to multiply this by 13 times 166 over 160, over 1. There. And same thing over here. 13 times 166 over 1. Now over here, I will allow 166 and 166 to cancel. And over here, I'll allow 13 and 13 to cancel, so that I have 13x equals 39. Now 13 does go into 39. I could have just had 3, but no, let's stay honest. Times 166. Now, we're going to divide by 13. Oh, this is totally sneaky. Look at this. 3 times 13 is 39. So 13 goes into 39 3 times. So x will equal 3 times 166, which is 166 times 3, which is 498. So we would guess there are 498 fish in the lake, and I'm going to put myself on the line and guess 498 and not be surprised whether it's either right or wrong. Yes, I am surprised. Okay, that is working with proportions, and we are now 1 minute over time. Does that make me cry? No. I think you should all grow up to be conservationists, or better yet, grow up to be math teachers. Even if you're 85, you can always grow up some more. So see you tomorrow when we will start, I think, the really exciting stuff.
Thank you.
Okay, bye.
Miss Barber, I'm going to stay on that question and copy. I'm going to see. Oh, can you go back to that question?
Yes.
I'm going to go ahead and just write that down so I can know for future. I just wanted to text them.
Let me make it bigger. But it's in your homework. Oh, no. Oh, there. That's the biggest I can make it.
That's perfect. And throws them back into lake.
Now I can make it a lot bigger. Ha ha ha. There.
Awesome. Okay. Miss Barbara, what I have done is that every 2 weeks,